Welcome to Lesson 6, Partitioning Segments. Example, use a directed line segment to model a situation. Which situation could be described mathematically by a directed line segment? A runner makes one lap around a track. An adventurer hikes the Appalachian Trail. A plane flies straight from Los Angeles to New York City. A boat sails from Los Angeles to New York City, passing through the Panama Canal. Alright, a directed line segment needs to be directed, so having a direction, a starting and an ending point, and the line segment is a straight line. So your runner makes one lap around a track that's circular, and the starting and ending points are the same. So I'm not going to choose that one. An adventurer hikes the Appalachian Trail. So to hike a trail, you have in my mind, I would have the same starting and ending point because I would want my car, I'd want to make it back to my car. So if I hiked up, I would want to hike back down so I can make it to my car. So I'm not going to choose that one. A plane flies straight from Los Angeles to New York City. Okay, well, straight is a line. Los Angeles to New York starting is from Los Angeles, and New York City is the ending point. So that one sounds fairly good to me. Good job. So it starts out at Los Angeles, ends, and the plane travels in a straight line from one point to another. Okay, so the next example, calculate the location of a point between two other points. Use points P, -3, -5, and Q, 11, 23 to find the coordinates of point R, which is located 1/7 of the way from P to Q. Okay, well, if I look at my graph, I do not have enough coordinates to graph 11 and 23, the point Q. So I'm going to just graph it roughly on my Word document. So point P is, I'm going to just roughly graph it, -3, -5. Okay, and Q is 11 and up 23, which would be way higher. But that's Q, and here's P. And so, to find the coordinates of point R, which is located 1/7 of the way from P to Q. Okay, so if I were to draw my line, I'm headed up to Q. That is the direction I am heading. So I want to be 1/7 of this distance right here. I want to be 1/7 of that. And that's somewhere where R is going to be. Now that is not 1/7, but that is what it's meaning. If I were to break this up into 7 pieces, I want to be 1/7 of the way along it. And we want to find the coordinates of that. Okay, so draw points P, -3, -5, and Q, 11, 23 on the coordinate plane, and then draw a right triangle such that the directed line segment PQ is the hypotenuse of the triangle, and the legs are aligned with the X and Y axis. Okay, so aligned means going parallel to. So the hypotenuse has to be PQ. So that's fine. Now, aligned means parallel to. So I'm going to draw a line that is parallel to the x-axis and a 90-degree coming straight down from Q, because this line is aligned with the y-axis or parallel to it. And that's our 90-degree angle. So I'm looking for a graph that has the direction ending at Q and has a 90-degree angle with alignment along the X, or the side along the a horizontal line, and a vertical line. So this one looks a lot similar, but if I notice, it starts at Q and ends at P, so I'm not picking that one. This one looks like the one we drew. It starts at P and ends at Q, and it is aligned or parallel to the x-axis, and this leg is aligned with the y-axis. So that is the graph. Okay, so now calculate the difference in the x-coordinates by subtracting the starting x-coordinate from the ending x-coordinate. Remember that the starting point is P, -3, -5, and the ending point is Q, 11, 23. Okay, so they set it up, but I want to know, why are they asking me to find the difference of the x-coordinates? Okay, well, if I find this x value and this x value, and I subtract them, and I subtract them, that's finding the horizontal distance, which is what we've been doing this whole time. So they want us to find the horizontal distance, or the length of this side. So they set it up. So 11 minus -3. So they labeled Q as x2 and P as x1. Why, might you ask, would they label it that way? That's because P is our starting point and Q is our ending point. Okay, 11 minus -3, double negatives, that turns into our addition. So 11 plus 3 is 14. Awesome, so this length right here, we know, is 14 units long. Okay, now find 1/7 of the difference. So why are we finding 1/7? Because we want to find 1/7 of our ending distance, and we're going to create a similar triangle that is 1/7, 1/7 this way, 1/7 this way, and 1/7 that way. Okay, so now I want to find out how long is 1/7 of that distance. So this distance, 14, what is 1/7 of it? So let's break this down. 1/7 I know I can write as 1 divided by 7 of, in math, is represented by multiplication, the difference in the x-coordinates. Well, that's 14. So I'm going to have an math statement that says 1/7 of, or times, 14. And you can type that into your calculator, and that will come out to be 2. Here we go. So, well done. We're halfway there. The next thing we want to find, I'm sure this is telling us, is the vertical total distance, so we can find 1/7 of that distance. So calculate the difference in the y-coordinates by subtracting the starting y-coordinate from the ending y-coordinate. Okay, again, it's because we have a direction. Q is our x2, P is our x1, x2, y2, x1, y1. So now to find the vertical distance, we're using the y-coordinates. It's just a vertical number line. So if you can find distance on a number line, you can find a distance on a vertical number line. It's just tilted straight up. So 23 minus -5, this becomes addition. 23 plus 5 is 28. Well done. This distance is 28 units long. Now I want to find 1/7 of that distance. I want to find 1/7 for this height. So what is 1/7 of it? Okay, whoops. 1/7 of the difference. And again, this is written out. 1/7 of is multiplication 28. So then you would type it in your calculator, 1 divided by 7 in parentheses times 28, which comes out to be 4. So that means that on our similar triangle, the 1/7, this height is 4. And remember, the horizontal 1/7 portion was 2. So now we want to find our coordinates. Well, I don't have to find that hypotenuse distance because I can count my coordinates. You have a starting point, which is P, and we know that on the graph, I will draw it on our graph right here. P is at -3. If you know that is your starting x coordinate, -3, -5. Okay, there's our P. If we know that this is our starting x coordinate and the 1/7 length is 2 units long, then I can count 1, 2. That's -1. So my x coordinate for R is going to be -1. Hey, looky. -1. Which, if we count, would be right here. And then the reason why we add 4 to the y coordinate is because we started at this point, which means our y starting value is at -5. And then we would count up 4 units because that is 1/7 of the total distance of our original triangle. So this is going to be up 4 units. So -5, and counting 4 up is going to end at -1. So that is why it says that you can find the coordinates of the point R by adding 2 units to the x coordinate, because 2 units horizontally represents 1/7 of our total horizontal distance. And then adding 4 units to the y coordinate is because 4 represents 1/7 of our total vertical distance. So then our coordinates are -1, -1. And the reason why we use P, the x coordinate and y coordinate of P, is because we started at P. Alright. Now, concept B. Partitioning with 1/n and other fractions. Alright, derive the midpoint formula. Previously, you learned that the midpoint between 2 points in the coordinate plane can be calculated using the midpoint formula. x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. As it turns out, this formula can be derived from our new formula, x1 plus 1 divided by n times the quantity x2 minus x1, and the y-coordinate of y1 plus 1/n times the quantity y2 minus y1. Let's Suppose we have points A at x1, y1 and B at x2, y2. If we want to find the midpoint of the segment AB, that is the same as traveling 1/n of the distance from A to B, where n, this denominator, is representing how many sections we have. So if I'm cutting a line segment, or we want the midpoint of it, that means I want half. So that means I want the segment to be in 2 pieces. Alright, so 1/n, the n is 2. When we substitute 2 for n in the formula, x1 plus 1/n times quantity x2 minus x1, and the y-coordinate of y1 plus 1/n times quantity y2 minus y1, we have x1 plus 1/2 times x2, the quantity x2 minus x1. That means when we substitute, that means we replace every n with a 2. So that is what they did here. Then if we distribute the 1/2, okay, so what they did to distribute means they multiplied everything in the parentheses right here with 1/2. That is something we can do. So 1/2 times x sub 2 is x sub 2 divided by 2, minus x1 times 1/2 is x1 divided by 2, plus, and then they did the same thing for the y coordinates. Okay, to simplify the x and y coordinates, we need a common. Alright, well, we have these fractions right here, and in order to add or subtract fractions, we have to have a common denominator, which is the lower portion of the fraction. Denominator. Okay, so the denominator is 2. After finding a common denominator, alright, how did they go from x1 plus x sub 2 divided by 2? How did they find that common denominator? Every value that did not have a denominator of 2, they had to multiply by some form of 1 so that the value of it didn't change. And the form of 1 that they chose was 2 over 2. Our denominator is 2, and 2 over 2 is a form of 1 if we were to reduce it. So what they did is they did x sub 1 times 2 over 2. X sub 1 times 2 over 2, which ends up giving us 2x times x sub 1 all divided by 2. And they did the same thing for y sub 1. Because they wanted the common denominator to be 2, they multiplied y sub 1 by 2 divided by 2, which gives us the 2 times y1 divided by 2. If you notice, your numerators stuck together and your denominators stick together. So then we have 2 times x sub 1 divided by 2 plus x sub 2 divided by 2 minus x sub 1 divided by 2 for our x coordinate, and our y coordinate is 2 y sub 1 divided by 2 plus y sub 2 divided by 2 minus y sub 1 divided by 2. Then we combine the numerators to have 2x sub 1 plus x sub 2 minus x sub 1 all divided by 2. That was the whole point of finding a common denominator, is so you could write the numerators all together divided by the common denominator. Alright, so after simplifying, we get the midpoint formula. Well, let's look at this. We have 2x sub 1s plus an x sub 2. Well, x sub 1 is not the same as x sub 2. But we have minus x sub 1. So we can combine these two because they are like terms. They both are x sub 1s. So 2x sub 1 minus x sub 1. Well, I have two of them here, and I'm taking one away. So that leaves me with 1 x sub 1, which is right here, plus x sub 2. That value did not disappear. It is still there. And then they did the same thing for the y coordinate. We have two y sub 1s. Well, y sub 1 and y sub 2 are not like terms, but 2y sub 1 minus a y sub 1 is going to leave us with 1 y sub 1, which is represented here, and that y sub 2 didn't go away. It's still positive y sub 2. So the mathematical symbol should be an addition sign. It's right there in the formula. It didn't change. Alright, we have derived the midpoint formula now. Okay, calculate the location of a point between two other points. Okay, so the calculate the location, and my little one is joining us, of a point between two other points. Suppose a platter is placed so its base is at point P0, 0, and its top is at point Q, Q10, 30. The ladder has 10 rungs, and Samantha walks up 7 of them. What are the coordinates of Samantha's location? Okay, before I read anything else, I'm thinking, alright, it has 10 rungs, so there's going to be 10 sections, and she walked up 7 of them. So she walked up 7/10 of the ladder. So the first step in solving this problem is determine the direction of the directed line segment that represents the ladder, because the base of the ladder is point P, which is at the bottom of the ground, and the top of the ladder is at point Q, and Samantha's climbing upward. She is traveling from point P to point Q. The next step is to determine what fraction of the way Samantha travels from point P to point Q. Because the ladder has 10 rungs and she walks up 7 of them, the fraction m over n is equal to what? Okay, so I had talked about this before I had, just to make sense of everything. There's 10 rungs, that is 10 sections, so that is our denominator. Our denominator is always the number of sections it has. And then she walks up 7 of them, so that's our numerator. So she had walked up, our fraction is 7/10. Great job. Alright. Because n divided by n is equal to 7/10 in this problem, you should use the formula x sub 1 plus 7/10, because that's our ratio or percentage that she walked up. Times x sub 2 minus x sub 1, and y sub 1 plus 7/10 times the quantity y sub 2 minus y sub 1. What values should you substitute for x sub 1, x sub 2, y sub 1, and y sub 2? Well, this goes back to our starting point, P and Q. P is at point 0, 0. So P is our x sub 1, y sub 1. So x sub 1, P was at 0, 0. Q was at 10, 30. So Q is our ending point, so that's going to be our x2, y2. P is our starting point, so that's x1, y1. So x1, I'm just going to look for x1s that are zeros. So far, these last three have them. Then I'm looking for an x2 that has 10, because that is Q's x2 x value. And the only one that has that is this one. y1 is 0, and y2 is 30. Alright, there we go. Okay, at this point you have determined that you need to calculate the following coordinates. Alright, where did these numbers come from? They substituted x1 for 0. So everywhere there was an x1, they plugged the number 0 in instead. And everywhere there was an x2, they replaced it with 10. So that is where all of these numbers came from. To simplify these coordinates, so now we need to simplify them. Okay, well, if I'm not grand at mental math, then what can I do? I can use a calculator. We want to find the x-coordinate. So I'm going to type in this statement right here, this math expression for the x-coordinate, and find a value for that. And I'm going to remember that 7/10 is written in parentheses when I type it into the calculator. So here we go. 0 plus 7/10. Alright, we had parentheses 0 plus, oh, hold on. He is not a happy camper. Alright, so we had parentheses 0 plus parentheses 7 divided by 10 parentheses times parentheses 10 minus 0 parentheses parentheses. Alright, and that comes out giving us a value of 7. Oh, sorry, bud. Alright, so her x-coordinate is 7. And I'm just going to write that down. 7. Alright, then I'm going to do the exact same thing for the y value. And we're going to type it in to our calculator. We're going to type in for our y coordinate 0 plus 7/10. Write that in parentheses times parentheses 30 minus 0. Alright. So 0 plus parentheses 7 divided by 10 close parentheses times parentheses 10, well, that was 30, 30 minus, oh, that was 60, 30 minus 0. That's going to give us 21. So the coordinates are going to be 721. Parentheses, because it's a coordinate, 7, 21.